So the first example reads like this. Aman and Bala had a total of 5 pencils between them. Bala had 3 more pencils than Aman. Find the number of pencils between them. So we have to make equations to solve this question. Aman and Bala had a total of 5 pencils between them. So A plus B is equal to 5, where A represents the number of pencils with Aman while B represents the number of pencils with Bala. Bala had 3 more pencils than Aman. So the second equation would be B is equal to A plus 3. Now there are two methods to solve these two equations. The first is the method of substitutions. In method of substitutions, we are going to put the value of A or B from the second equation to the first equations. It's easy to put B is equal to A plus 3 in the first equation. So our first equation will become A plus 3 is equal to 5, where I have put the value of B is equal to A plus 3. So my new equation will become 2A plus 3 is equal to 5. If I take 3 on the right hand side, so it will become a minus. So 2A is equal to 5 minus 3, 2A is equal to 2 or A is equal to 1. Now if I get the value of A is equal to 1, I can put in either first equation or second equation to get the value of B. So B is equal to A plus 3, which is 1 plus 3, so B is 4. This is our first method, that is method of substitutions. There is another method which is method of elimination. In method of elimination, we will try to either eliminate A or B from the equations. So our first equation is A plus B is equal to 5. In method of elimination, I want all the variables in the left hand side and the constant part on the right hand side. So rearranging the second equation, I get a minus A plus B is equal to 3. I have shifted A to the left hand side, so it will become a minus A plus B is equal to 3. Now I can see that the coefficient of A being 1 and minus 1. So if I add these two equations, A plus minus A will get cancelled. B plus B is 2B. And on the right hand side, it's a 5 plus 3. So 2B is 8 or B will be 4. Now if B is 4, I can back substitute the value of B in any equation to get the value of A. So A plus B is 5. A plus 4 is 5. So A is. So these are the two methods to solving linear equations in two variable. Let's look at the other example, where 3A plus 2B is given as 7 and 4A minus 3B is given as 15. Now it's been very difficult to solve these equations with the first method, that's the method by substitution. So I'm going to use the method of elimination. I can see that coefficient of A in the first equation being 3 and 4, while the coefficient of B being plus 2 and minus 3. To make the coefficient of B equal, I have to multiply first equation with a 3 and second equation with a 2. I have taken the LCM of 2 and 3, which is 6. So I have to make this 2 as 6, I have to multiply it with the 3. So the first equation will become 9A plus 6B is equal to 21, while the second equation will become 8A minus 6B is equal to 30. Now if I add these two equations, 9A plus 8A, which is going to give me a 17A plus 6B minus 6B will get cancelled, which is equal to the right hand side of 30 plus 21, which is 51. So A will be 51 divided by 17, which is 3. If A is 3, I can use this equation to get the value of B as well. So 3A. So 3 multiplied by 3, 9 plus 2B is 7. 2B will become 7 minus 9. So 2B is minus 2, or B will be minus 2 divided by 2, that's a minus 1. So A is 3, and B is -1. Let's take another example. 4 years ago, Arjun's age was 4 times that of Bhim. 3 years hence, Arjun's age will be thrice that the age of Bhim. Find Arjun's present age. So let the present age of Arjun and Bhim be A and B respectively. 4 years ago, Arjun's age will be A minus 4, while that Bhim's age will be B minus 4. So our first equation is A minus 4 is equal to 4 times that of B minus 4. A minus 4 is 4B minus 16. Or I can get the value of A as 4B minus 12. After 3 years, the Arjun's age will be A plus 3 while Bhim's age will be B plus 3. So according to the given condition, A plus 3 will be thrice of Bhim's age, that is thrice of B plus 3. So if I solve this, I get A plus 3 is equal to 3B plus 9, or A will be 3B plus 6. So I can see that A is equal to 4B minus 12, A is equal to 3B plus 6. I can solve this equation with the help of any method. But from the logic, I can see that it's better to use method 1, which is the method of substitution, because I get the value of A in the left hand side. Four B minus 12 is 3B plus 6. Shifting 3B on the left hand side, 4B minus 3B, only B, and minus 12 on the right hand side, so it will become a plus 12. So B is equal to 18. If I get B equal to 18, I can substitute the value of B equal to 18 in this equation or in this equation to get the value of A. Let's put B equal to 18 over here. So 3 multiplied by 18 is a 54. 54 plus 6, 60. So the Arjun's age will be 60 years. Let's take one more example of numerators and denominators. If the numerator and denominator of fractions are both increased by 1, the fractions become 1 by 2. If both are decreased by 1, the fractions become 1 by 3. Find the fractions. Okay. So let the new fraction be x upon y, where x is the numerator and y is the denominator. First condition, if both are increased by 1, so the numerator will become x plus 1, denominator will become y plus 1. So x plus 1 divided by y plus 1 is equal to 1 by 2. Let's look at the second condition. If both are decreased by 1, fractions become 1 by 3. So x minus 1 divided by y minus 1 is 1 by 3. Okay, so let's solve this. If I cross multiply, I get a 2x plus 2 is equal to y plus 1. And 3x minus 3 will become y minus 1. So I can see that 2x plus 1 is y, whereas 3x minus 2 is also y. So let's solve this. 2x plus 1 is equal to 3x minus 2, or x is 3. If x is 3, I can solve for the value of y. So let's use this. 2x, which is 2 into 3, 6 plus 2 is y plus 1, 8 is equal to y plus 1, so y is a 7. So the required fraction, which is x upon y, x by y is nothing but 3 by 7. So let's move to the next part, which is forming equations with numbers. For example, I have a 2-digit number 23. So I will read this 23 as 10 multiplied by 2 plus 3. So if the number is 45, I will read this as 10 into 4 plus 5. If the number is xy, where in the unit digits it's a y, in the tens digit it's a x, so I will read this as 10x plus y. Similarly, yx, which is the reverse of xy, is nothing but 10y plus x. If it's a 3-digit number, 365, it's 100 into 3 plus 10 into 6 plus 5. If it is given in the form of variable, which is ABC, so ABC is nothing but 100A plus 10B plus C. XYZ is nothing but 100X plus 10Y plus Z. So let's solve one example based on digits. The questions read as, sum of digits of a 2-digit number is 8. If the digits are interchanged and the resulting number is subtracted from the original number, we get a 18. What is the original number? Okay, so let the number be xy, where xy is nothing but 10x plus y. And the reverse number of xy is nothing but yx, where yx is equal to 10y plus x. So the first condition given as sum of digits of a 2-digit number is 8, which means that x plus y is 8 if the digits are interchanged. So original number xy, reverse number is yx. If the digits are interchanged, the resulting number is subtracted from the original number. So 10x plus y minus 10y plus x is given as 18. Solving this, 10x plus y. Now if I open the bracket, minus 10y, and this minus 1 into plus 1 is a minus x, which is 18. So 10x minus x is 9x plus y minus 10y is minus 9y, which is equal to 18. If I take a 9 common, I will be left with x minus y is 18, and I can cancel out this 9 from left hand as well as right hand side. So I will be left with x minus y is nothing but 18 divided by 9, which is 2. Now I can see that x plus y is 8, x minus y is 2. Simply by adding this to equation, I get 2x, y will get cancelled, so it's a 10, x is a 5. And if I put x equal to 5 in this equation, I get 5 plus y is 8, or y is nothing but 8 minus 5, which is a 3. So my required number is xy, which is a 53.